Yeah, hello everyone, I'm Starkaður Barkason. I will be chairing this session. This title of the session is Resources and Usage, and we will have 6 presentations for the next 2 hours, so it's 20 minutes per presentation, and so each talk should be around 15 minutes, and then we have 5 minutes for questions and hopefully answers. And we are starting with Tanja Visik. She's from the Austrian Center for Digital Humanities and Cultural Heritage, and she will talk about research infrastructures and terminology work.
Thank you very much. The aim of the talk today... Yes. The aim of the talk today will be which role research infrastructures have in terminology practice, especially in institutional settings, and in particular which role CLARIN and CLARIAH have in terminology practice, and if there are still no connections point, which could be the possible connection point between research infrastructures and the community of practice in terminology. So terminology for this study is the activity of aiming at ordering concepts, describing concepts, and assigning designation to concepts and vice versa. So it's every type of terminology work, so not only systematic terminology work, but also ad hoc terminology work or translation-oriented terminology work. Infrastructural approach to terminology work is not new. Already in 1998, Galinsky made a model to systematize the stakeholders in terminology work. But obviously at that time, research infrastructures were not part of the picture. In more recent studies, there were connections points between terminology work and research infrastructures, but still there was no clear overview about what role CLARIAH and CLARIN have in terminology work in institutional settings. To do this study, semi-structured expert interviews were conducted, and these semi-structured expert interviews are part of a bigger project that investigate the role of technological change and cultural change in terminological work. The inclusion criteria for the expert to be interviewed were that they should be working in an institution that perform practical terminology work and maintain a publicly available terminology database or publicly available terminological dictionaries, and be actively involved in practical terminology workflows on a regular basis. So for this study, terminology work in company settings were excluded. The interviews were transcribed and anonymized. So regarding the profile of the interview participants, there were different types of institutions included. So academic institutions and non-academic institutions, so public administrations, European institutions, and international organizations. Different roles in the terminology workflow were covered, so terminologist proper, terminology manager, technology manager, IT developer, or members of terminology committees. And all types of terminology work are covered. So we had systematic terminology work, ad hoc terminology work, translation-oriented terminology work. And also different languages were involved, lesser resourced languages and well-resourced languages. This is an overview of all the participant interviews that were anonymized, and it's only given if they were like a CLARIN, the institution was in a country that is CLARIN member or CLARIAH member, and if they are working with less resourced languages. Because giving a profile with the specific language could make one of the institutions clearly identifiable. So if I say this institution is working on Maltese, this could be really referred to to the specific institution, and then they would not be anonymous. So this was the solution to to group them if they were less resourced language, working with less resourced languages or with well-resourced languages. So since it's a larger study, not all the questions asked in the interviews were relevant to this study, but the questions that were relevant for the specific study I'm presenting today were: which source material do you use? Do you use corpora? Do you create your own corpora? And do you publish them? Is the terminological data, so the end result of the terminological work, stored and archived in a repository? Which steps in the workflow are done automatically? And which tools do you use beside terminology management systems? And of course, do you collaborate with research infrastructures such as CLARIN and CLARIAH? The method of the data analysis was done via thematic qualitative text analysis, and the interview data was annotated with CADMA. And the results I'm presenting today are grouped in the following thematic themes. So, use of corpora, publishing corpora, use of archives and repositories, use tools, and collaboration with research infrastructures. For the results, I will bring examples, so excerpts from the interview data, because it's a qualitative study. So all of the, regarding the use of corpora, all of the interview participants said that they are using existing corpora for ad hoc terminology work. So ad hoc terminology work, for those that are not familiar with ad hoc terminology work, is the terminology work that is done for one specific term. For example, there is a consultant service, the public is asking for the usage of one specific term or for the translation of a specific term that is coming up, and then the people in charge of terminology work are researching if there is already a term used in this language community, or they have to create a new term. So for this, existing corpora are used alongside other resources like already existing dictionaries. For the other type of terminology work, so for the systematic terminology work where terminological dictionaries, terminological glossaries, or new domains are fed into terminological databases, for this type of work, most of the institutions interviewed are creating their own domain-specific corpora. Regarding the publishing of these domain-specific corpora that they are creating, not many of them are publishing their corpora. So one obvious reason is obviously copyright issues. So here is an excerpt of an interview that when they were compiling the corpus, they were not paying so much attention about the copyright issues, and it would take too much time to follow up with the copyright holders to get permission to publish it, so it was only used internally. Besides copyright issues, also the perception of the corpora that they create, that they are only a working material, so that's not the final product, but it's only a step in the process to go to the terminological resource, is also a reason why they are not publishing the corpora. So they are only used in-house. And often it's also underestimated that the resources that are collected, when they are not annotated properly, so if the corpus has no part of speech tagging, for example, it's not something that others could use or would find useful. So this is also a reason why the material is not published. Regarding the issue of use of repositories or archives, Regarding the use of repositories, only one participant used the data repository to archive the final terminological resource in a data repository that also happened to be a CLARIN B-Center repository. Others were not familiar with this type of using a data repository as an additional way of publishing their terminological resources, or they had the idea to approach an archive or repository to deposit their data, but they were approaching the wrong archive. So an archive that is not specialized in language data, and so they turned them back. So they didn't want their data because they were not specialized in, not a specialized language data repository as the CLARIN B centers are. Also, the tools that were mentioned during the interviews were systematized, and there's a broad range of tools that are used within terminology work. So there are a huge part that is about data management concerning the terminology, data management concerning the corpora, and also data management concerning translation. Because if you remember, there are also these translation-oriented terminology work scenarios covered by this study. And then there is a huge part of tools that are regarding communication. And the tools are regarding the licenses are commercial tools or open source tools, and regarding the development, they mentioned tools that were in-house developed, tools that were developed in cooperation projects, off-the-shelf tools from companies, or the tools were outsourced and developed by a company, but with their own specifications. So they provided the specifications to the developers. So especially regarding the tools here regarding the corpus data, and also some tools that are for terminology management, there is a potential where there can be collaboration and connection points with CLARIN. When asked directly about collaborations with research infrastructures, all of the institutions, the academic institutions and the non-academic institutions, said that they have a huge variety of collaboration with other institutions. So also the non-academic institutions had collaborations with universities, were in networks for terminology work and things like that. But specifically collaboration with research infrastructures, there were only few that really have direct collaborations with CLARIN. Most of the academic institutions said that their institution have collaboration with CLARIN or DARIAH, but their specific unit working on terminology work did not have direct connections. So they were aware of CLARIN, they know that CLARIN or DARIAH as a research infrastructure and the institution per se was part of it, but their specific group was not collaborating. Others that were aware said that they are not yet collaborating, but that they are considering the collaboration in the future. And especially terminology groups that were situated in public administration, so in non-academic institutions, were not aware of CLARIN and DARIAH, which is also a similar picture that was elaborated by the LSE white papers. So all of the interview participants use already existing corpora and for ad hoc terminology, and most of the interview participants create their own specialized corpora for systematic terminology work. So, but these specialized corpora are rarely published. So there is a potential in this area of they are working with corpora for collaboration with the research infrastructures. And we clearly saw in the study that there are differences between academic and non-academic institutions, that academic institutions are aware of CLARIN and DARIAH, but this does not necessarily mean that even if the institution is in the network, that the specific people working on terminology work are collaborating or using services from CLARIN or DARIAH. And non-academic institutions were not familiar with CLARIN and DARIAH. So to conclude, the role of research infrastructures in terminology work in institutional settings has potential, but it's still expandable. There's especially potential for collaboration for lesser, like for institutions that work on lesser resourced languages. And if we have this goal to expand our user base also to the non-academic sector, so especially the public sector, one possibility would be to include CLARIN ambassadors, or to include in the CLARIN ambassador program also persons from the public sector to promote our services also in the public sector. Thank you very much.
Thank you, Tanya. Obviously, we have possibilities to expand in CLARIN. I mean, we are working with corpora, with tools that we have to offer, but somehow they don't know about it or don't take the step. We have time for 1 or 2 questions.
If you look at commercial terminology in the commercial sector, or at least in the non-academic sector, I would guess that they will work with corpora that are internal to the company in many cases, and these are corpora that they cannot get from CLARIN, and these are corpora that they cannot share with CLARIN, probably, because they're company internal. So how do you see a potential for working with CLARIN for those kinds of terminologists?
In this study, the companies were not included, like it was the public sector, and for the public sector, like open data is on the table, but they are not seeing like the language data as part of this open data. So this is something we could expand on for the public sector. For the companies, it's right that often these materials that they're using are restricted or they would not use it, but to get a real good overview about that, a study with those industries would need to be conducted.
One thing that we have in CLARIN with regards to is of course the concept registry, and we have not been stressing that for some time too much, but of course there are working groups that have other terminology solutions. Do you think it would be recommendable or required for us in CLARIN to have something like a working group on terminology? So a working group dedicated to terminology, working with some things like the concept registry and the various national terminologies that are around. Would you recommend us to do that?
I think it would be a good starting point to collect all these. For example, in DARIAH, there are working groups that are working on thesauri, for example, or on lexical data. And in CLARIN, I mean, terminology is like everywhere in CLARIN, but it's not specifically labeled somewhere. And if somebody from outside comes and don't see this label immediately, then they maybe are not going deeper in there. So I think if it's more visible somehow, that would be a good strategy.
Thank you very much, Tanya, for the very nice presentation. And I think it's a very nice use case. Here.
sorry.
It's a very nice use case that I've observed the same idea in other domains. So this is a use case with terminology, but in other domains or areas as well, where people prefer to build new resources instead of reusing existing resources. So I just wondering, what is your opinion about how, where do we stand as CLARIN infrastructure in terms of the R from the FAIR, so the reusability, and what would be your advice, of course, for this use case, but maybe could be generalized to other areas as well, how to boost data reuse or tools reuse instead of continuously building new things?
I think one aspect of this reuse is really visibility. Like the first step is really the visibility. If it's not visible, even if it's like theoretically fair and accessible, if it's not visible immediately, then the barrier to reuse it is bigger.
Okay, let's give Tanya good applause. Thank you. Next on stage are Lilja Björk Stefansdóttir and Anton Karl Helgason. And they are going to talk about how they have been using the Icelandic Gigawatt Corpus to explain lifespan change.
Thank you. We are working on a project that is called Explaining Individual Lifespan Change, or ILIS. And this is a 5-year project that is funded by the ERC, the European Research Council. The project crucially makes use of CLARIN resources to carry out research on socio-linguistic lifespan change, which is the study of how individuals change their use of language over some period in their lives. And in this project, we have been focusing on Icelandic politicians, and in this talk, we will give one example of such a study. We will be focusing on a case study of one Icelandic politician where we use the Icelandic Gigawatt Corpus to examine syntactic lifespan change in the speech of an Icelandic member of parliament, Mr. Bjarni Benediktsson, who is currently the Prime Minister of Iceland. The study as a whole has a primary focus on developing explanations within socio-linguistic theory, the study of language variation and change in its social context. But at the same time, it exemplifies the benefits of using a CLARIN resource for big data digital humanities. The Icelandic Gigawatt Corpus contains 2.4 billion words, and a part of that is parliament speeches, and these allow us to track the evolution of Icelandic politicians with a high time resolution, sampling speeches from each year in their career and observing gradual changes on a continuous time axis. And for some background, there now exist several studies on how individuals change their way of speaking over the course of their lives, generally referred to as lifespan change. And most of these studies are not high-definition studies, meaning they are often based on just comparing 2 or 3 periods in someone's life rather than a continuous time axis. There are some exceptions, like Sankov 2004, who sampled data from this TV series 7 Up, checking the speech of her subjects at 7-year intervals. One new method involves the so-called dynamic panels, where samples are taken from 2 or 3 time points, but the speakers are taken from different age groups, so the entire age range of the community is represented. However, despite various methods that have been tried, the lack of a fine-grained view has been an underlying problem in the study of lifespan change. Studies of lifespan change are difficult because ideally we would want to carry out repeated socio-linguistic interviews with the same speaker over a couple of decades. Now, this is just time-consuming and in most cases just not possible. And even lifespan studies that focus on publicly available recordings often focus on just 2 or 3 periods because the transcription work is so time-consuming. Now, in our study, we use publicly available transcripts and audio recordings of 18 years of a political career in the Icelandic Parliament. These are not socio-linguistic interviews, but the speech is still relatively natural, and we have an abundance of data to analyze. And we can illustrate the benefits of our high-definition method by comparing one leading study in this field, Sankoff and Wagner 2006, with our 2017 study of another Icelandic politician, Steingrímur Sigfússon. The two-period study plots straight lines between two time periods, whereas the high-definition study shows a wiggly or sort of spaghetti-shaped curve that goes up and down over time, and the ups and downs can be associated with events in the career of the politician in question. Now this detail, this going up and down, this would be lost if we only had the first and the last data points.
As in other language variation and change studies, our study focuses on a certain linguistic variable, which refers to when there are two or more ways of saying the same thing. Our variable is the Icelandic stylistic fronting, an optional movement of a head or a phrase to the front of a clause that has a phonological subject gap. Stylistic fronting is a sociolinguistic variable, as its only clear meaning component is a sociolinguistic one. It is associated with formal style. Here you can see an example of sentences with or without stylistic fronting, and the contrast between the word orders illustrates the movement's optionality. Bækur sem lesnar eru til skemmtunar eru bestar. Here we have the sentence with stylistic fronting, and this is the more formal version. Bækur sem eru lesnar til skemmtunar eru bestar without stylistic fronting is less formal. Although full phrases can be stylistically fronted, we only focus on the canonical cases here, as we limit the scope of the study to word orders involving the complementizer sem that introduces Icelandic relative clauses and finite auxiliaries and non-finite main verbs in either of the two possible word orders. We do this to control for factors that can condition the use of stylistic fronting, building on findings from Wood's 2011 study, which showed that prosodic factors and syntactic category can affect the rate of stylistic fronting. Obviously, this does not include all cases of stylistic fronting, but it allows us to extract a well-defined envelope of variation with high accuracy. So we look at the movement in relative clauses, and as I said earlier, the variant with the movement is the more formal one. Then we show graphs like the one here, where the y-axis shows the percentage of stylistic fronting, and the x-axis shows time, or the age of the speaker, continuously. As previously mentioned, the Icelandic Giga-word corpus consists of 2.4 billion running words of text, and part of the corpus is parliament speeches. This resource allows for a high-definition time resolution, where we can observe gradual changes over time where the time axis is continuous. We wrote a Python script that analyzed part of the corpus, the parliament speeches given by Bjarni Benediktsson between the years 2003 till 2021, and we extracted sequences with a relative complementizer followed by a finite verb and a non-finite one in either of the two possible word orders. The corpus includes audio files and transcriptions, making observation for accuracy possible as we can listen to each audio file and verify the transcription. The pattern that we search for are very reliable, as confirmed by our manual checks. Before we can talk about results, I want to take a minute to talk about models of style shift, because our study is based on a variable that is associated with formal style, so any changes in the use of the variable can be referred to as style shifting. That is, when people change their speech either by becoming more formal or less formal. Style shift has often been analyzed in terms of situational surroundings, such as the attention that a speaker pays to their speech at a given moment. According to Labov's attention paid to speech model, the probability of using formal variants correlates positively with the attention that a speaker pays to their speech. The more aware the speaker gets, the more likely they are to use formal variants. In addition to situational effects, style shift can also be interpreted in terms of the so-called linguistic marketplace, a long-term style predictor that explains the relationship between speakers' linguistic behavior and their linguistic market value. Individual linguistic market value is highly connected to their social status, which is shaped by personal and professional experience over the years, and a high linguistic market value correlates positively with the probability of using formal variants. Note that a speaker's linguistic market value may change or evolve due to various events in their lives, such as getting a new job, getting into a position of responsibility, becoming a parent, etc. So in our current study, we are tracking the use of stylistic fronting in the speech of the now Prime Minister Bjarni Benediktsson, and we focus on the period before, during, and after the economic crash of 2008. Benediktsson is an interesting subject for many reasons, but let's just say he's had a rather turbulent career and that he is a key figure in Iceland's political history. Here we see a graph of Benedictson's use of stylistic fronting from the year 2003 till 2021. In the early years of his career, the circled area, Benedictson's rate of stylistic fronting is relatively high, with the average rate of 91.16% in the years 2003 till 2007. This pattern is not an unexpected one, since Benediktson was a new MP at the time, and the situational effect of his surroundings and new status is likely to have caused him to become more aware of his language use, which positively correlates with a frequent use of formal variants such as stylistic fronting, according to Labau's attention paid to speech model. In addition to situational effects, the high rate of stylistic fronting during this period can also be interpreted in terms of Benediktson's linguistic market value, which was high during this period, both as an MP, but also as an MP for a party that was in government and therefore in a strong position within the parliament, resulting in his speech becoming formal. However, this trend is reversed in 2008 when the rate of stylistic fronting suddenly drops, going from 97.6% in 2007 to 83.3% in 2008. The rate continues to drop in the following years, the circled area in the graph, reaching its lowest rate in 2011 at 66%. This decline in the use of stylistic fronting is interesting because it occurs almost simultaneously with the Icelandic economic crash of 2008 and during the crash's aftermath, which lasted till the year 2012. The economic crash took a big toll on Benediktson's party, the Independence Party, as it had been part of the so-called crash government, which collapsed in early 2009 and lost a lot of support from its voters, with many looking at the party as the culprit for the economic crash. We analyzed this change in Benediktson's linguistic behavior as a reflection of a dramatic change in his linguistic market value due to his weak political position at the time, as his party had lost their seat in government, as well as facing the lowest support in the history of the party. This temporary change is again reversed in 2012, when the rate of stylistic fronting increases again, when the aftermath of the financial crisis is mostly over and Benediktson and his party start to prepare for the upcoming elections, which took place a year later. The 2013 elections resulted in the Independence Party regaining their status as Iceland's biggest political party, and Benediktsson took on the role of Minister of Finance in a right-wing government. Perhaps unsurprisingly, the rate of stylistic fronting continues to be relatively high in the following years, as it is well above 50%, reflecting Benediktson's high linguistic market value as a person in a position of power. An analysis of Benediktson's use of stylistic fronting in the period before, during, and after the financial crash confirms that the various nuances of individual lifespan change can only be studied in a large digitized corpus. If we had, for example, only the first data point and the last, many crucial aspects of the development would have gone missing from the picture, no matter how carefully the data would have been collected. Note that an analysis of lifespan change has to be evaluated on a case-by-case basis. For example, in our study of Ásmundur Daðason, we believe that the aspect of identity are more important than linguistic market value. However, we do see from our many studies that the notion of the linguistic marketplace seems to apply in every analysis, at least to some extent. In this study, we used a CLARIN resource, a corpus containing the speeches of the Icelandic Parliament, to analyze the formality level of one politician, Bjarni Benediktsson, over time. This builds on our previous work on other Icelandic members of Parliament and continues to demonstrate the value of open access data for the digital humanities. We found that fluctuations in the use of stylistic fronting by Benediktsson reflects explanation given by the literature on style shift, as it connects with his attention paid to speech and linguistic market value over time. Thank you.
Thank you very much. So, any questions?
Thank you very much for your presentation. I was wondering whether you also look or could consider what happens in the debates, for example, at the same time, or in his parliamentary group, because I have the impression that you are influenced in language by the people you communicate mostly with. So whether this change in time is also in his parliamentary group, for example.
We have been looking at the parliament as a whole and also at the development for specific parties. And so these changes are always change from that direction. There's always something different. From the general pattern, which means the government as a whole. But it is often that their party goes in the same direction, for example, during the financial crash. So we see a big difference between left-wing parties and right-wing parties during that period. And then the specific MPs usually follow their party's pattern. Okay.
I have a question on the number of data points you have changing relative frequency between the formal pattern and the informal pattern, but you have only one speaker and it's over many years. So how many data points per year do you roughly have?
You can see this. Yeah, I thought it was supposed to be on the picture, but like the bigger data points, they are what? Do you remember, Anton? More than.
This is like a few hundred, I think.
Yeah.
Okay. So yeah, I have no idea how frequent the pattern is. So,
yeah. Sorry, it should have been included in the graph.
Yeah, it usually is. Yeah. So yeah, I mean, the bigger data points and even the not as bigger, there's pretty substantial amount of data behind them.
Okay, so the differences are significant here.
Yeah, you show here the coincidence of, let's say, a linguistic phenomenon with, let's say, an event in the real world. That's just one-on-one correspondence. Do you have independent evidence that, let's say, these two phenomena are somehow related, and now you see that they coincide, but you would like to know whether there is a causal connection, of course, and you could support it by having, for example, other phenomena in Icelandic that have a formal and a less formal variant, and do they correlate in the same way, or maybe completely different phenomena? That would strengthen, let's say, the point that these two events are related, and otherwise they could be coincidental.
Could you repeat the main point, because I didn't quite hear it?
Well, the main point is you have just show one phenomenon, one linguistic phenomenon. Do you have other linguistic phenomena that also show, let's say, a change correlated to this event in the real world?
So the stylistic fronting variable is the primary variable for the study, but we are also, we haven't started on doing it yet, but we have a couple of other variables that are also associated with formal style. They're just a bit more complicated to do manually, but no, not manually, I mean automatically, but we are working on it. But our stylistic fronting variable has been working quite well for us. We've been doing a lot of studies, but yeah, I mean, we're going to do other variables and also phonological variables. We're going to look into dialects and all of that.
Are you considering other parliamentarians to include in your research? Because I believe there are parliamentarians that are for decades in parliament, not only prime minister. So.
Well, just to clarify, our subject, he was not prime minister during this period, or only for a couple of, but yeah, we've been looking into other parliament members, if you were asking that question. I'm sorry, I have a bit trouble hearing, it's like echoes a bit here. But yeah, we've been looking into 5 or 6 others, and the plan is we're going to look into many others, many more, and also, as I mentioned, the parliament as a whole, and different parties as a whole. So we're looking into many different aspects.
Thank you.
Thank you.
So this Bjarni Benediktsson, he just terminated the cooperation of the government 2-3 days ago. So it would be interesting to know how he is speaking today. Yeah. But you mentioned the Icelandic Gigawork Corpus, and now we are going to get the father of the Icelandic Gigawork Corpus on the stage. But he's not going to talk about the Gigawork Corpus. He's going to be talking about evaluating capabilities of MT systems in translating idiomic expressions using a specialized dataset.
Thank you. So I'm Steinþór, and I'll be talking about a little project a few people at the Árni Magnússon Institute in Iceland have been working on evaluating how good MT systems are at translating idiomatic expressions. So we're using a data set that we put up on CLARIN 2 years ago by some of the same people. containing idiomatic expressions, and when I talk about idiomatic expressions, I'm talking about expressions that have non-literal meaning. So the meaning cannot be inferred from the meaning of the individual words, but usually are some sort of a metaphor or a simile. Overview of the talk. So I'm going to start talking about the dataset, just describing it a bit. Then I go on to talking about machine translation and multi-word expressions, how we use the dataset for evaluation, and finish by a short discussion. So this Icelandic English dataset is compiled for use with machine translation. So we thought, so it contains 1,000 Icelandic idioms from Íslex, which is an Icelandic Scandinavian dictionary project. So dictionaries from Icelandic into the Scandinavian languages. And we translated these, or 1,000 idioms from there into English, listed with English idiomatic equivalent, literal meaning, and examples. And the idea was to use this for augmenting training sets or training machine translation, or for evaluating machine translation. And we hear it has been used for training machine translation, but that's anecdotal. There are no papers, but we have been told it has been used that way. So this dataset is available on CLARIN. An example, so this is the idiom sýna sitt rétta andlit, which would be show one's true colors in English, and then we have a source sense, so what it means in Icelandic, what it means in English, examples in both languages, and a keyword in Icelandic. When we talk about multi-word expressions, so multi-word expressions are kind of a problem, or can't be a problem for machine translation, because often they just translate words individually. An idiom is a kind of a multi-word expression. There can be others, like fixed or semi-fixed phrases. Fixed phrase could be like on the other hand, or as a matter of fact, something like that. An idiom, an example would be to kill two birds with one stone, which is sort of a metaphor. Phrasal verbs can be like look into, break down, something like that. And collocations are just words that commonly appear together, like excruciating pain, for example, the pain you feel when a mosquito stings, for example, recent example from my life. But it can be a bit difficult to provide clear boundaries for multi-word expressions, so we stick to idiomatic expressions here. This table is actually fairly recent, so this is from a paper that will be published next month. So this is an evaluation in the other direction. I just wanted to show that because it shows how bad translation systems are at translating idioms. So this is from a shared task on, or test suite shared task from WMT, the Conference on Machine Translation this year, describing results for an English Icelandic set. So that's a new set that was created in the other direction. And we can see there the idiom accuracy, the systems, I think there are just two systems that go up or above 50%. So usually they fail in most of these things. And this paper looks at both idiom accuracy, so accuracy of translating idioms, and literal accuracy. So we have two like pairs to see if the systems can differentiate between when the words are used as an idiom or when they are just used literally. So an example would be, if I take the example with kill two birds with one stone. So I killed two birds with one stone and went to the grocery store while waiting for the dentist appointment. And the other one would be the great Cossack hunter was out of bullets, but managed to kill 2 birds with 1 stone. So Cossacks are great hunters, I understand. Anyway, so this is an example of that. So how badly they fail the idiom accuracy, but the literal accuracy is usually better because these systems tend to translate word by word, really. And these are the latest systems. So the Claude is scoring the highest, but the Claude 3.5, and that's actually, I think, the system scoring highest for most tasks at the upcoming WMT conference. But back to the other data set. So we are translating from Icelandic into English in the talk I'm talking about. We compare 3 empty models. So one model I made last year, which is just a transformer big model. It's trained on an Icelandic corpus, parallel corpus called PAR-ES, which I filtered a bit more than, or a bit further, and added heavily filtered paracroll data also. So there's a fine-tuned MBART model which also uses PAR-ES, so it's pretty much the same data, but they also use back translations and then Google Translate as of last spring. We use automatic evaluation, start doing that using Blue, CAREF, and something we devised called AutoIE, Automatic Idiomatic Expression thing. So what is that? It's just a simple approach. It checks if the translation has key content words. So we looked into the content words for the expected translations. If the translation has this key content words, we assign it a pass, so it's correctly translated. Otherwise, it's assigned a fail. So this is the results we get. It's pretty much in line with the Blue and CAREF scores, actually. But it still indicates that very few idioms are translated correctly. We also do a manual evaluation. For that, we had a professional translator just manually evaluate each translation. We had 3 options, so it's correctly translated, it's incorrect, and it's understandable. So that means it's almost correct, but there's something a bit off, which a human translator would not do, but the reader will understand it. And this is also in line with the automatic scoring. So what we think then is that the automatic scoring is actually telling us what we need to know if we want to select a machine translation system that's best at translating or least bad at translating idiomatic expressions. We could use our automatic method, even though it's not perfect. So there are some observations. Some of these are kind of maybe a bit obvious. So idioms that can't be translated word by word are most likely to be correct. That's because that's how these systems work. They translate often word by word. Sigurður var úlfur í sauðargæru. It's just the same as Sigurður was a wolf in sheep's clothing, so it's the same metaphor, really, and it gets translated correctly. But if the idioms are translating into an idiom that has the same meaning but uses a different metaphor, it often fails, or usually it fails. Sigurður eldri en tvær vetur, it means Sigurður is older than 2 winters old, which means Sigurður was not born yesterday. It usually fails on stuff like that. All these systems do. So the results. As I said before, NT systems, even fairly new ones, and those using large language models, as seen in the recent WMT results, commonly fail when translating idiomatic expressions. But our simple approach provides results in line with a manual evaluation. So it indicates that it may be sufficient for helping to select the best system for this task if needed. So in some translation tasks, this is more important than in others. So if you're trying to translate literary texts or even social media texts, it's usually richer in these metaphors or idioms than if you're translating European Union regulations or stuff like that, which is usually quite dry. Then this may be a factor in what system to choose. So this data set we have is actually, we think it's good enough for this translation direction to evaluate that. Of course, the obvious limitation here is that we are only looking at one translation direction in our project. We're actually in the WNT project, we're looking in the other direction for the same language pair. In our set, we have 1,000 idioms. These are selected from the Icelandic Scandinavian dictionaries. We can't say whether they are on average harder or easier to translate than the ones that are not included in the data set. We did not set any, like, I mean, we did not try to evaluate if they're hard or easy. We just selected like a random selection from these dictionaries. And also, which is actually probably why we get higher scores for the manual evaluation than for the automatic evaluation. It's almost double the scores for some, or it's more than double for some systems, is because in the dataset we usually just have one translation, one idiomatic translation for each given Icelandic example, but sometimes when we have an idiom in one language, we can translate it using different idioms in the other. So the MT system might select some of the idioms that we don't have in our dataset, and still it's correct, perfectly valid translation. But it fails in our automatic evaluation while the professional translator who manually evaluated it accepts it. So a future direction would be to enrich this dataset a bit more. One way to do it would just have to have multiple MT systems generate multiple translations, manually evaluate these and check if some of these are adding idiomatic expressions that are good, that are correctly translated, so we could add that to our dataset for future use in order to get better scores with the automatic method. So that concludes that.
So yeah, we have questions already.
So thank you. It's always good to show that there is still work in machine translation, and it's not reaching human parity as sometimes is claimed. This being said, I have a question on what's the frequency of the idioms in your test set in, for instance, the Giga word corpus. Are they of the same frequency, or some of them might be very rare? And yeah.
That's a good question. We actually haven't looked at the frequency for these, but I think when we chose it, so we created a dataset 2 years ago, and these idioms, none of them are like something that none in the group had heard before. So it's like something that most people would understand. But no, we didn't. We should actually take a look at that. It would be interesting to see how common.
That would probably not occur in your regular test set for blue score.
No. I mean, occasionally you have idioms there, and the blue score may be good because it translates some of the words, and I mean that's how blue works. But I think blue completely fails to evaluate this well. Even though, I mean, probably systems that are good. In general, they are better at idiomatic expressions, so that's why we see this tendency. But I don't think blue sees this really, not so much.
So it's probably not in the trading data of the MT systems if they're relatively low frequency compared to.
Not exactly this data set, but probably some of the expressions are in some of the data. So we don't know about it. Of course, we don't know anything about Google Translate.
No. It would be worth checking what the frequency is in your gigaword corpus.
Yeah.
To maybe have different categories of idioms.
Yeah.
There.
Yeah, this actually would be interesting. There's, I think, a lot of stuff to be done in looking at idioms in a short way. Yeah, anyone else?
Okay, so we are on track again. Time, thank you. And now it's Begonia Altuna and, well, Iker Garcia Ferraro. He's going to talk about clickbaits.
Hi everybody, I hope you are ready for the presentation that will change your lives, because today I am going to speak about clickbaits. I am going to speak about Noticia, a clickbait article summarization dataset for Spanish. So first of all, what is a clickbait? A clickbait is exactly what I did right now, create very high expectations for something that is not going to be that interesting. An example of a clickbait article could be an article with the title, "This is the date in which the Earth is going to be destroyed." This is a very interesting title, because if you see this, you really want to read this article, because if the Earth is going to be destroyed in the next 2 weeks, you don't want to go to the office tomorrow. So people will click into this article. And what happens when you click into a clickbait? What you get is an article that is very long. Usually it has a lot of paragraphs, but these paragraphs are not relevant. They don't provide you useful information. And at the very end of the article, you have a sentence that says, the Earth is going to be destroyed at some point in the next 2,000 billion years or something like that. So that article is useless. But why does somebody write an article like this? Because it makes money. When you click in one of these articles, you have a very long text. In this text, you have a lot of ads. And as you scroll down through the web, you see all the ads, you generate a lot of revenue for the website, and they make money. And why this is bad? Because, first of all, I hate clickbaits, so they are bad. And they are also bad because they create a problem for people that actually do good journalism. Because if you have a good article next to an article that says that the Earth is going to be destroyed, you probably are going to click in the one about the Earth getting destroyed, because it's like something very important, or something that you want to know if it is going to happen. So people that write good articles find that they don't make money. People don't read these articles, and in the end, they just start writing clickbait too, because they need to make money. So this is a problem, and the amount of clickbait in the web is growing really fast. So we want to build tools and datasets to fight this. But I'm not a superhero that wants to fight against clickbait. I'm an NLP researcher, so why do I care about clickbaits? I care about clickbaits because they are a really interesting evaluation task for LLMs. In order to summarize a clickbait article, the model needs to understand the title. It needs to understand that the title, this is the date in which the Earth is going to be destroyed, is creating a question that is, when is the Earth going to be destroyed? And then it needs to search through a very long article that has a lot of words, a lot of paragraphs, just to find a very small piece of information that says the Earth is going to be destroyed in a lot of billion years. So if a model is able to do this task, it means that this model has very good text understanding capabilities. So this is the dataset that we have built. We have 850 clickbait articles that we have summarized by hand. We call this task ultra summarization because, as you can see in the bottom, the articles has an average length of around 600 words, and the summaries has an average length of only 10 words. So we are not doing a regular summarization task. We are just finding the piece of text that responds to the title. If we say the Earth is going to be destroyed, we don't care about any other information that is not the date in which the Earth is going to be destroyed. So it's an ultra summarization task. And the dataset is very diverse. We have a lot of topics, for example, celebrities, economics, science. They are very different articles. And all of them are in Spanish because in this work we focus in Spanish, but we want to do other languages soon. So the way we have annotated these articles is by hand, using 2 native speakers that have read all the articles, all the titles, and they have read the summaries. And it was a challenging task. And they have also annotated the test. Both of them has annotated the test set, so we can compare the annotation from both humans. And what we found is that in around 25% of the articles, they write exactly the same answer, letter by letter. In around half of the times they write an answer that is very, very similar. It just changes a word or something very small, but the answer is basically the same. Then we have around 20% of the articles in which they have write an answer that is different, but both of them are valid. For example, in the Earth is going to be destroying thing, maybe one has written in a lot of billion years and the other one in 200 billion years. So the answer is different, but it's just the same, or both of them are valid. And then we have a small percentage in the data set in which there is a disagreement. This disagreement usually happens because one of the annotators did the annotation wrong, because it's a really challenging task. You need to read a lot of text, and sometimes you just make a mistake in the annotation. So in this case of disagreement, we have manually reviewed the annotation and fixed them. So then what we did was evaluate a lot of models in this dataset. We have a lot of public models or open source models, and we have also evaluated ChatGPT because it's what people use generally. So we also want to know how good is this model, even if it is not open. And the way we evaluate models is in a zero-shot setting. We have a prompt explaining the task to the model. We give to the model the headline, the text, and the model needs to generate a summary. We don't train the models. We don't have few shot examples or examples because the texts are very long, and if we add examples, the model, it doesn't fit in the context window of the model. And the more challenging thing here is how do you evaluate the output of the model? How do you compare the output of your model with what a human has with the summary that a human has written? We have read a lot of papers, test different ways of evaluating this task, and what we found is that the most simple metric, that is the root score, works great. It correlates with the perception we have of the quality of the models when we manually review the outputs. So we want in the future to use better metrics, but for now, this one works great. But the problem that this metric has is that if you write a very, very, very long summary, you are going to get a better score than if you write something very short. So we also take into account the summary length, because we want a summary that has a very high root score and is as short as possible. And we have also fine-tuned some small models in the task, build some task-specific models to see how they perform. We have trained models from 2 billion parameters up to 10 billion parameters. And the way we did this was taking the training split of the dataset that has 700 articles, and we train the model with these articles, and then we test them in the test set. And I don't know if you can see the results here, but the important thing is that Llama 3 and GPT-4 are the models that perform best in a zero-shot setting. They are quite good in the task without any training or any example. And this is not surprising because they are the models that have been trained with the more amount of data, more GPUs. They are the more modern models, so we were expecting that they will be the best ones. But the really interesting thing is that the task-specific models that we have built, especially the 10 billion parameter model and the 7 billion parameter model, are very, very, very close to the human baseline. The human baseline is computed as as comparing one of the annotators against the other one. And these models write summaries that are very similar to what a human will write. So, and they are also very small, so you can use them like in production or use them to crawl the web, finding clickbait articles and summarizing them, or something like that. And they are much smaller than Llama and GPT-4. Here is a small comparison of how the model performance correlate with each of the annotators, because we have two annotators, so maybe two different humans will write two different summaries that are going to be very different, but we found out that this doesn't happen. If you evaluate the models against one of the annotators and against the other one, the results are similar, are the same, so different humans write the same summaries. And very quickly, the errors that we find in the models. The most common error is that the model writes a very long summary. Instead of writing a summary that just answers the headline, they write a general summary of the article. That this is something that we don't want in this dataset. Fine-tuning fixes this, but in serious setting, it's difficult to make the model to produce a very, very short summary. And another mistake that they sometimes make is that they don't understand the headline or the text. Sometimes the answer of the model doesn't have anything to do with the headline. For example, in the Earth is going to be a straight theme, maybe one model starts speaking about, I don't know, where is the moon or something like that, that is not related to the headline. And with the fine-tuned models, these task-specific models, we have found that if we increase the number of articles in the training set, the root score keeps growing. So this says that if we annotate more articles, we will get even better models. So we should annotate more to get better models. And well, here I have a summary of the presentation, but I'm not going to explain it myself because we have a really cool demo here that you can scan and you can summarize any article you want, any clickbait article. And the demo is in Spanish, but it will probably work in other languages. I'm not sure, so try it and see what happens.
Thank you. This, we have questions.
Thank you, very nice presentation, very interesting. I missed which base language model are you fine-tuning your clickbait fighter?
Is Nose Hermes Solar is the 10 million parameter model. The 7 billion parameter model is OpenChat, and the 2 billion is Gemma. Okay. There are better models now, but when we did this were the best ones.
Hi, thanks for the really nice presentation. In your evaluation, you penalize longer summaries. Is that why the task-specific system works better than the other referenced models, you think?
Yeah, I think that the task-specific models are better because they understand the task better, because they know that they need to write something very short, so they get better scores. And I think that maybe, I don't know if with a better prompt, but if you make GPT-4, for example, understand better the task, it will probably work better than the small models. And yeah, I think that...
Because you used those models in a zero-shot setup, I think. So maybe they don't understand that you want a shorter summary.
Yes, and they usually write very long summaries, and we want something very short, but it's very difficult to make this model understand what we want, because they have been trained with a lot of summaries from website or whatever, so they have a very clear idea or preconception of what they need to do, and we don't want a regular summary, so it's very difficult to make the model not do a regular one.
And it doesn't help if you would include a couple of examples in the prompt, like some in context learning.
Yes, that will probably help a lot. We didn't do it because of the context windows issue. Right now we have models that have a youth context window, so now it could be possible to do that. In the past it was not possible. But yeah, we have a lot of things that we think that it could improve. But that's why the data set is public, so anybody can test this type of ideas.
What should I do to make sure that Clickbait Fighter does not recognize my text as clickbait? I'm just asking for a friend.
You should write a headline that doesn't create a question, because if the headline doesn't make a question, the model doesn't know what to do, and the summary that writes doesn't make sense, because or it just copies the headline. So if you don't write something like, instead of writing, this is the date in which the Earth is going to be destroyed, you write, the Earth is going to be destroyed in 2,000 billion years, it's not going to work. But you are probably not going to get clicks from people. Thank you.
Thank you. And now, the fifth on the panel, it's gonna be, well, is it Tess or, yes?
So, hello everyone, my name is Tess. I'm a PhD student at the Ghent Center for Digital Humanities, as well as the Language, Technology and Translation team at Ghent University. And I will be introducing some of the work that we are doing currently on the creation of workflows for digital humanities, where we will add a component on generative LLMs, or at least that is what we are exploring and going to disseminate in a later stage. So first I will go over the what we are doing exactly and why we are doing it. So the difficult marriage between natural language processing and digital humanities as a field. Then I'll talk a bit about generative large language models and their potential and also their disadvantages or possible pitfalls for literary historical data sets. Then we'll go over the gaps and goals of my research. And then we will move on to the how. So I will introduce some of the workflows that we have created, some of the code that we have built using generative AI and also other tools, and how we intend to disseminate those workflows in a later stage. And then last but not least, we will go over the when, so the work that is still in the pipeline and the workflows that we still want to create and disseminate in that same manner. So natural language processing in digital humanities, by which I mean the application of natural language processing to literary historical data sets, still remains quite the challenge. Because we are dealing with historical languages, of course, there are still the OCR quality of these data sets is not always great, which always has an effect, a detrimental effect on the results of information extraction systems, for example, or classification systems. We are also dealing with stylistic features. If you think about it, literary historical texts, there are a lot of metaphors that are used, for example, which makes tasks such as sentiment analysis extraordinarily difficult. We have a data lack in digital humanities, so we do not have a lot of data available since they are historical sources. They still need to be digitized, etc. And they are also not always annotated. And even if that annotated data is available, there is still quite the technical skill gap in the digital humanities, because natural language processing is not always part of the curriculum. Wow, that was a difficult word. So we don't always know how to get started with modeling. Now, in come generative large language models, and they are now being tested for information extraction tasks across domains. I have found them being evaluated and used in, for example, the biology domain, in the medical domain. But what about literary historical data? Like, what would their purpose be there? So in DH, we are always a bit slower to adopt methodologies from NLP. We are always a bit reluctant, and the same goes for large language models. And it does make sense in a way that we are reluctant, because they come with quite a bit of challenges. So we know that they have a propensity to hallucinate results that we may not necessarily want, especially for an information extraction task, for example. They are not really transparent. We don't really know what kind of data they were trained on. And they have also a propensity to propagate a bias, for example. They are not always privacy friendly, really depending on the type of model that you use. If you use a closed source model such as ChatGPT, if you use it in the chat interface, we do not always know what they do with your data. There are no standardized evaluation methodologies currently in place for prompting methodology, so that is also a difficulty. We know that if we change one word in our prompt, it can completely change the output of that we expect or do not expect. So that is also quite an issue, and of course there is an explosion of models currently going on. So it's very hard to have an oversight of the field, what is going on, how many models are out there, and which models can you use for specific tasks that you are interested in solving. However, despite all of these difficulties, which are quite a few, I think that there is also quite a bit of potential in these models, because these models, they really signify a paradigm shift in the sense that you do not have to know everything about modeling practices to use them. You can just talk to them in natural language, which may lower the threshold for people from the digital humanities to use these models, or at least start experimenting with these models in their work. Another advantage, I would say, is that they have zero and few shot capabilities, so they do not need heaps of data to have them nudged in the correct direction or the direction that you want them to go in. They're known to be flexible across languages, so I would say that there is still a lot of untapped or unknown potential there. So the goals of overall my PhD research are actually to answer to the calls for more methodological research on the crossroads between natural language processing and the digital humanities. And more specifically now, given the traction that is gained by these generative LLMs, I'm trying to really zoom in on these type of models and explore their potential in literary historical research contexts. And the goal really is here to actively involve the DH community in this red-hot debate surrounding this model type. So our approach is really just to dive in and see what happens, basically. So what we did is we collected a data set first, and then we used this data set to cater to both the perspective of computational linguistics. So we use it to benchmark a couple of approaches, test a couple of approaches, evaluate them. And then in the future, we also want to use this data set and other data sets to cater to the digital humanities lens. So for hypothesis testing, basically, where we start out from a research question and try to solve this research question using generative AI or other tools in natural language processing. And then the third step, which is mainly what I will be discussing today, is the dissemination of these this code, of the steps that we took, as workflows. And I know that workflows is an extremely vague word that can mean everything, but in our case, it basically means every research that we undertake, we translate all of the code, all of the steps that we have taken into Jupyter notebooks, just kind of to demystify the steps that we have taken, which I think will be a good step to involve the DH community a bit more, because it's easier to grasp, easier to understand. So on the collection of the data sets, one of the data sets that we have collected and annotated is one on travel literature. So we have collected 3,320 texts from all kinds of online sources, ranging from the 18th to the 20th century, and in English, French, Dutch, and German. We have annotated them with entities as well as with sentiment. So all of the entities that you can see here, they are related to the environment, to biodiversity. So they are ranging from weather to biome to fauna to flora, etc. And then we also annotated sentiment on the level of the sentence as well as on the level of the entity. And we annotated this on the level of the entity so that the dataset could be used to make aspect-based sentiment analysis systems where you basically you give an entity a sentiment score because we hypothesized that this would be more useful for digital humanities research as it is more fine-grained as opposed to approaches that do that on the level of the sentence or the document, for example. So what did we do with that data set? We built a couple of approaches. So for one paper that I have written, I explored a couple of approaches that we can take to build aspect-based sentiment analysis systems. So, and then I compared these approaches both quantitatively and also qualitatively and see how they performed. So I built a rule-based, aspect-based sentiment analysis system as well as a machine learning-based one, and then also one that is based on generative AI using the mixed-role instruct model. And then in a second step, so that was one paper. In a second paper, I also explored the capabilities of the models that are available in the GPT-4All tool suite. GPT-4All is a really nice tool, actually, because it allows you to download models on your local system. It has a lot of models available, generative AI models, which you can download. They are between 4 gigabytes and 8 gigabytes in size, and you can use them on your local system. This is completely open source. It's very user-friendly. So I also evaluated a couple of these models for named entity recognition to extract fauna and flora from my texts. And all of these workflows were then put into Jupyter notebooks. In Jupyter notebooks that were structured in kind of the same way. So first I give an overview of, okay, what are we going to do? What is the background knowledge that is needed for completing this task? And then the code that we used for all of our approaches, so all of the prompts, and then the input and the output that is expected in formats, and then also some information on the advantages and disadvantages of each approach. Next to that, I also showcase, using the same data set, a couple of tools that are open source and can be, according to me, really interesting for digital humanities, such as Spacy's Entity Ruler, and also GLINER, I'm not really sure how to pronounce it, which is also a zero-shot model which you can easily integrate in your NLP pipeline. And I basically show in a simple notebook, okay, so this is my data set, I have fauna and flora entities, how do I use GLINER, for example, to extract these fauna and flora entities, and how do I evaluate it based on my annotated data? The same goes for the TARS model, which is also a zero and a few shot model in the FLAIR framework, where I basically do the same thing. I showcase it on the same data set. And in the future, I am thinking about building a relation extraction system using ChatGPT and RAG, but of course we cannot use the data set that I have introduced for this because it was not annotated for this task. But we are aiming to apply this methodology to a set of correspondence from Guido Gezelle, who is a well-known poet and priest in Belgium from the 19th century. And these letters are in French, English, and Dutch. And I want to try and see if I can build a methodology based on generative AI, based on ChatGPT and RAG, to extract personal relationships from this correspondence. We also share some other code snippets which are basically just useful, such as we show how to transform your data to a bio format to then evaluate your named entity recognition system. And also we show you how to bootstrap annotations using an open source model, and then feeding the output of that open source model into an XML, and then feeding that XML into an annotation platform. Just kind of the basic steps that you need to undertake, some of the knowledge that is often implied in NLP papers, but which can be confusing or a bit obfuscated for people from the digital humanities. So this is a link to the GitHub where we posted all of the Jupyter notebooks that we have made up until now. So as I said, they are very structured. The idea is to communicate it in a transparent manner without necessarily oversimplifying the steps that we need to take. There is really a focus on the required background knowledge that you need for each approach and the pitfalls that you need to take into account. And indeed, so every workflow uses the example data set, and you can basically load it in and play around with it yourself and see what happens. But, okay, so another thing that I wanted to say is that I also published the annotation guidelines there. The data itself is completely available, and also the publications that are linked to these workflows. So, what I was kind of missing here is because when we build an NLP pipeline, a lot of the processes, they remain kind of invisible. So during the annotation process, we also had a lot of findings. It is not easy to annotate a literary historical corpus, to push a discriminative approach on this type of data. So what I was missing is in these Jupyter notebooks, if you start writing about all of your perspectives and all of your views on this process, then the Jupyter notebooks, they become very long. And that is something that I wanted to avoid. So I also started a blog on Medium where I share those kind of perspectives, more in a kind of a storytelling-like fashion. So it's easy to follow, and it also goes beyond the code. But I have to say, I posted this on Medium, but ironically, this is not the best medium because it is behind a paywall, and that is not what I wanted. So I am going to migrate this to another platform which is open source and accessible. So if anybody has any suggestions on which could be an adequate platform, I would be happy to hear it. So on to the when, to future work then. So what I wanted to do next is now we have mainly focused on the perspective of computational linguistics, so really benchmarking models and methods. But now I want to move more to the hypothesis testing. So indeed, starting from a literary historical research question, how can we use these tools to solve that question? And we want to try to do that with generative AI, with zero and few shot tools, and see where we get. And indeed, as I said before, one of the methods that we still want to test is the relation extraction, to extract personal relationships from Guido Gezelle's correspondence. And then we also want to test GLI-NER multi to extract artists from French salon catalogs, not salon French catalogs. And we want to see how well that this tool performs. We have already conducted a case study on using the machine learning-based APSA system to analyze comments on fan fiction on Greek mythology, and then this was analyzed by a historian who was specialized in the subject, Julia Neugarten. So that was a nice way to see these two worlds and these two methods come together. In the future, we also want to have a look at the correspondence of François-Joseph Navet and Beauvoir. So Navet is a painter from Belgium as well, and Fien Messens, a researcher at our faculty, is working on his correspondence. And she would be interested to see what the personal relationship would be between Beauvoir and Navet and how we can analyze this in a digital way. So that could also be a challenging task. Another task is that we want to look for traces of Percy Shelley, who is a well-known poet, in suffragette journals to see how often he was referenced, how often his poetry was referenced. And then something that we were also thinking about is tracing the overlap between romanticism and meta-lyrics, because we think that style-wise there is probably still a lot of overlap between like the more morose, the more melancholic way that meta-lyrics are often expressing themselves, and romanticism as poetry. Okay, so this was basically it. I'd be happy to hear your suggestions and questions.
Thank you for a very inspiring presentation. You mentioned Jupyter notebooks multiple times.
Yeah.
And I was curious whether you actually tried to use them with people that are completely uninitiated to programming, like they have zero background. Because we had a similar discussion in my department with a colleague about what's the best way to make our tools accessible.
Yeah.
And some propose this notebook, some think that it would be a disaster because you have to know how to think about the state of a program and so on. So I'm really curious about what your experience.
Yeah, we had a couple of interns from the CLS Infra project who came to work with us, and they had a little basis in coding, so they did know a bit of Python, but they didn't really know anything about natural language processing or like the ways that you would do that. And they said that for them it was really helpful to have it in a stepwise fashion and to also really see what the input data looks like and also what the output is supposed to look like, so they really know what to work towards. So they did say that that really helped, but one feedback that they did give was that, as I said, the notebooks were getting a bit too long because I was adding all kinds of information in there, and so yeah, that is why I also decided to extrapolate a lot of that information to the blog posts. Yeah, I hope that answers your question.
Thank you very much for this inspiring talk. Because you asked other possibilities to publish your material, have you thought about the CLARIN Learning Hub materials to publish your notebooks? And the other thing, like the longer blog post thing and the workflows, have you looked into the programming historian?
Yes. Yeah.
And the third thing that was coming to my mind was this workflow option in the SSH marketplace, where you could describe a workflow and then link the tools that are associated to it, would be also another possibility to sum up these workflows.
Yes, yes, indeed. What I really want to avoid is that this becomes kind of an isolated hub where they then disappear under the dust of all the bits and bytes. So I don't want to do that. I really want to make sure that they are integrated. I was talking to people from AI for Humanists as well, so they also have a kind of hub where they publish these kind of workflows, and indeed the integration in then other projects such as the programming historian and infrastructural projects will be, I think that is something that should be done in a stage where I feel like these notebooks are finished and ready enough to publish in that manner.
Thank you.
Okay, thank you.
Now, for a while we have had these word clouds hanging over us, but finally it started raining. And Magnus Althorp is going to talk about those word rains.
Yes, so my talk is titled Word Rain as a Service, which is because we already have the Word Rain tool, but now we have also made it as a web service. I'm from the Language Council of Sweden, and then also Maria Skeppstedt is also from the Center for Digital Humanities and Social Sciences at Uppsala University. So I just need to start by explaining what the word rain is, for those of you who don't know. Maybe you saw some of our examples at the poster session yesterday. But basically, you have all seen a word cloud. This is a word cloud in Swedish. And maybe you don't recognize the words because you might not read Swedish, but you can at least see the word argument here, which is the same in Swedish. What you really see here is that you see the most frequent words, but you don't really see much else. The infrequent words are more or less useless because you don't know where to find them. So you can, of course, look at a random place in the word cloud and then try to look there for words, but it doesn't really mean anything. So what we are doing with word range is that we order these along a sort of semantic axis, and then we order the words in prominence in the vertical axis. So by default, we use word2vec to use for the semantic axis here, and what this means is that we can actually zoom into this and actually make it mean something. So if we zoom into this argument piece here, then we can see that another word that you might recognize is ideas here, a little bit further down. And then there are, so words that are related will sort of appear at the same place here. Then what we do is that we also add bars to this, which makes it easier to get an overview where there are frequent words, but also makes it possible to compare prominence between different word ranges. So here we have an example in English. For example, we might be interested in something that has to do with warming there, so we zoom into that. And then we can see that we also have temperature, but there is some smaller words there, so we'll zoom into where we have the temperature there, and then we can see that at the same place as temperature we have heat, warm, moisture, cold, and so on. And then we can also see that we have some sort of chemicals and gases and so on there, which means that when we zoom in, we actually get some sort of meaningful information. But what's really important here is that word ranges are not for exploring semantic similarities. There are better tools for that. For us, it's just a tool to actually have some sort of order. What this also means is that you can have several word ranges. So here I have placed two under each other here, and all these words are on the same place at the x-axis in the upper one and the lower one. So we can, for example, look at medium, which you hopefully can see up there, just under mean. And on the lower one, you can also see medium. But if you have the word mean, for example, the word mean doesn't appear in the lower one, but it has a place. So it's when you generate these together, then they always have their place, even if they don't appear in that specific graph. So what has been available until now is the word range tool. This is highly configurable. You can set all sorts of parameters, but you have to download this, write a small program, and run it. And what this means is that there is some sort of technical knowledge barrier here, maybe not for many of you, but for other people, there is some sort of resistance to doing this, because even if you only have to write a small program or edit a small program, then people might not be comfortable with that. But there is also, even if you know a lot about this, then there's the time and energy aspect as well. You might not want to do this whole procedure just to test it out. So the solution here is to make a web service that is easy to use and has a limited feature set. I will now go through how this works. So the first thing you do is that you choose what language you want to use. And what this in practice does is that it chooses a word-to-vec model for that language. And right now we have support for Swedish, Finnish, Yiddish, and English. And the reason for those languages is because those are languages that are relevant for our case center. The case center for the languages of Sweden. And also we wanted English because that makes it much easier for people to test. So when you have chosen language, you choose how many number of words you want to plot, and here you can choose between 300 and 600. In the tool you can choose any number you like, but here we like to limit the numbers. Then we have advanced settings here, where you can choose between using IDF if you want that, and also you can specify a background corpus that is useful for the IDF calculations. But we will, in this example, we will choose bigrams, and I have a quite worthy explanation of bigrams here for people who are not comfortable with the word bigrams. But I will choose this. And then I will have to upload some data. So the data I've chosen here is from the European Parliament, House of Commons and House of Lords. This data is more than 100 megabytes. And we have configured the word range service to only accept 10 megabytes of data. So I have had to cut down this to 3 megabytes each. So I prepared some files here that are 3 megabytes each, and I just choose them and upload them, and I get some sort of upload progress bar. And yes, and when the data is uploaded, you get sort of an example here. This is not based on the data. This is just an example so that you can see what the parameters, what the effect the parameter has on the graphical result here. But for now, we just accept the defaults, and we get some processing progress bar here, and then we get the result in line on the web page as a PDF. So I think that the bars are a little bit too high. We can't really see the whole word range here. The bars takes up a little bit too much space, so we scroll up, and we just choose a smaller bar height. We change it from 30 to 20%, and then we redraw the word range, which is quite fast because we have already processed the corpus in the previous stage. So now we can see the result here, and we can experiment with the parameters. But I'm still not satisfied here, so I will go up again, and then I will change the word size fall-off rate, which is the relationship between frequent and infrequent words. So it means that you either compress this or expand it. So I will redraw it again, and obviously what I wanted here was that I wanted to make it more compressed, but I did the opposite thing. So I can see the result here that it's much more spread out. The words are much more similar in size, but I want to make them less similar in size. So I go up again here and drag the slider here, the word size fall-off rate slider, to the other side instead. You can see that it changes the small example there. And then also I drag the bar height to an even smaller one because I want to compress it even further. And I redraw this. And now it's perhaps less readable in this in this context here, but at least I have compacted it a bit. So what I do now is that I download this PDF and I look at the whole thing, and I can see all my 3 corpora in the same slide. And of course, you might not want this, you might want some other thing as well. If you saw the poster session yesterday, you might have seen our poster where we had the same data but very different parameters. We had more words here, and also we had it more spread out. So you can configure this quite easily and experiment with the parameters when you have processed the corpus, because the processing of the corpus takes the most amount of time, and then you can just play around with the parameters afterwards. So this is where you find this service. It's only meant for small things, because we don't want to make a service that can do everything and do it for very, very large data sets. It's meant for to experiment and to see what this word rain is all about, and also for people that are very non-technical, that just want to see, they might just have a text file and they want to get a word rain out of it. But for more advanced uses, you will have to download the tool and use it yourself. So, but at least you can still do the basic functions of the word rain. You can get one word rain, you can compare different corpora with each other and so on. Yes, thank you. So, any questions?
Any questions?
Thank you. Maybe a small suggestion. I think this would be an excellent service to be connected to the language resource switchboard, so that more people also get to see it. It would be very. It's not very hard to connect it, so we can discuss it during one of the breaks.
Yes, definitely. I mean, this is just the start of this. So.
You're using Word2Vec for this embeddings, but have you considered other word embedding models like?
Yeah. So if you download the tool, you can very easily just replace that, because it's even the very small program you write. The most amount of code is actually loading the Word2Vec model. Okay. So you can just replace that with anything that responds to the same. Same things, so it's very easy to replace with anything else.
Is it in Python or the program? The program. What programming language?
Oh, so yes, it's in Python.
Okay,
yes.
Thanks.
So adapting to another language would only be choosing the right Word2Vec model.
Yes, or it depends on what language it is, because we've also in the past worked a lot with Japanese, for example, and that's a much harder problem, because then you cannot how should I say, you can't just fool yourself but by thinking that space is a good word delimiter. Of course, space is not a good word delimiter, but we choose that anyway because that's the most practical thing to do. But in languages that don't have those kinds of word delimiters, you have to do something else. But otherwise, It's just choosing a vector space. Then, of course, if you want to have things like lemmatization, in these I've not lemmatized the data, but of course you can lemmatize it as well, and then of course you're more language dependent then. So, but we have done all these things, so there are examples.